At 11:47 p.m., the last departure gate closes. The terminal goes quiet. Families stop moving. Coffee cups go cold on armrests. To the casual observer, the airport is resting. But beneath the departure boards and duty-free displays, a second shift is just beginning. Ground operations never truly pause. They reorganize. While passengers sleep in hotels or lean against boarding gate windows, hundreds of workers begin their choreography on the tarmac, a choreography most travelers will never see. Every aircraft that departs at 6:15 a.m. has already been worked on for hours, its fuel calculated to the kilogram, its cargo redistributed for weight and balance, its cabin cleaned, restocked, and inspected. The morning flight is not a beginning. It is the end of a long night's work. The ground operations team operates inside a structure most people never consider. A layered hierarchy of roles that must synchronize precisely or the entire departure schedule collapses. One misstep cascades, one delayed truck holds 3 gates. At the center of this system sits the ramp control supervisor. Their role is not glamorous. It is, in the language of the industry, a coordination function. They manage aircraft pushbacks, ground vehicle conflicts, gate availability, and weather hold sequences simultaneously. Before any aircraft can be turned around, that is the industry word, turned around, a sequence of interdependent teams must arrive and depart in the correct order. It is a logistics puzzle, and it runs at major airports every few minutes. The fueling crew arrives first. They have a window, a narrow window, dictated by the flight plan and the fuel order submitted hours earlier by the flight dispatch team. Fuel uplifts are not estimates. They are calculations verified twice before the nozzle connects. Beneath the wing, the over-wing fueling technician watches the meter. They are not watching for drama. They are watching for precision. A kilogram too much and the weight and balance sheet must be recalculated. The captain is notified. A hold is placed on pushback. Meanwhile, the baggage operation has begun. Below the terminal, in the lower level baggage hall, bags are already moving. Conveyor belts carry them from check-in counters through automated routing systems down to the makeup area where loaders sort them by flight. The makeup area is its own operation. Here, loaders read bag tags, match them to flight numbers, and stack them onto unit load devices, the metal containers that slide into the belly of wide-body aircraft. Each ULD holds hundreds of kilograms. Each one is weighed. The system is designed to be seamless. In reality, it is managed chaos, held together by repetition and training. A misrouted bag, one that goes to the wrong sorting lane, can miss a flight entirely. The process for recovering it is not fast, and the passenger waiting at the other end will not know any of this happened. Upstairs, the catering operation runs on its own clock. Catering trucks, vehicles with hydraulic lift platforms that rise to meet the aircraft door, begin loading galley carts. Each cart is pre-built, meals counted by class, by seat, by special dietary code. Inside the catering facility, hours earlier, a team assembled those carts. They work from a manifest, a document that lists every seat and every passenger request. Vegetarian, gluten-free, infant meal, diabetic. The margin for error in this operation is considered acceptable at less than 1%. In practice, the teams push towards 0. The cabin cleaning crew boards the aircraft as soon as it parks. Their window is tightly defined, often 25 minutes for a narrow body, 40 for a wide body. In that time, they must remove all waste, reset seatbacks, replace headrest covers, check seat pockets, and prepare lavatories. They do not slow down. Some members of these crews have worked this shift for a decade or more. They know the aircraft better than many who fly them. They know which overhead bins stick, which lavatories drain slowly, which seat rows are always messier than others. This knowledge does not appear in any manual. On the tarmac below, the ground handling agents, often called ramp agents, are preparing the cargo hold. This is physical work. Bags are heavy, irregular, and time-pressured. The hold must be loaded to a precise configuration that reflects the load sheet above. The load plan is not a suggestion. It is a structural document. Placing too much weight at the rear of the aircraft affects its center of gravity at takeoff. The captain reviews the final load sheet in the cockpit before accepting it, before the ground crew receives clearance to disconnect. Simultaneously, the dispatch team in the operations center is finalizing the flight plan. They're calculating route options based on upper-level wind data, restricted airspace, alternate airport fuel requirements, and slot times assigned by air traffic control. Nothing is assumed. Everything is verified. At this same hour, the aircraft itself is undergoing its pre-departure inspection. The first officer conducts the walk-around, a methodical circuit of the aircraft exterior, checking flight surfaces, landing gear, engine inlets, static ports, and lighting systems. Every item on the checklist is actioned, not acknowledged. The engineering team may already be on site. During overnight layovers, scheduled maintenance tasks are performed. Not repairs necessarily, but routine checks, hydraulic fluid levels, brake wear indicators, tire pressure on each of the main landing gear assemblies. These are not optional checks. Inside the terminal, a parallel operation is underway. The overnight cleaning crews work through the public spaces, gate areas, food courts, restrooms, corridors, with an efficiency that is entirely invisible to the morning passenger who arrives and finds everything clean and ordered. Terminal cleaning at this scale follows a programmed sequence. Restrooms are checked on a rotation, every 30 minutes through peak hours, every hour through the deep night. Each inspection is logged, not for management review, for system integrity. Below the terminal, beyond the baggage hall, lies the infrastructure most travelers will never know exists. Miles of tunnels carrying electrical conduit, fuel pipelines, data cables, and mechanical systems. Maintenance workers move through these tunnels on scheduled inspections throughout the night. The fuel hydrant system, the network of underground pipes that deliver aviation fuel directly to aircraft parking bays, is one of the airport's most critical hidden systems. It is checked daily. Any anomaly in pressure or flow triggers an automatic alert in the fuel farm control room. In the fuel farm, the tank farm at the airport perimeter, automated systems monitor fuel, temperature, volume, and contamination levels continuously. Human operators are present throughout the night, not because the automation fails, but because the stakes of any failure are absolute. Back on the apron, the pushback crew is preparing their equipment. The aircraft tug, a low-profile, high-torque vehicle, will be positioned at the nose gear. A tow bar will be connected. The pushback sequence requires coordination between the tug operator, the wing walkers, and the flight crew. All communication runs on headsets. Wing walkers stand at each wingtip during the pushback, guiding the aircraft clear of obstacles. Other aircraft, jetways, ground equipment. Their role is simple in description, critical in function. They are the margin of safety between a controlled pushback and a very expensive collision. In the air traffic control tower, the night shift controllers have been tracking the arriving and departing aircraft for hours. This is not their busiest period, but the work never drops to zero. Cargo flights, repositioning flights, and late arrivals keep the frequency active through the early morning hours. The runway lighting system is its own infrastructure. Runway edge lights, centerline lights, approach lighting sequences, touchdown zone lights, all are maintained by the Airfield Technical Services team. A burned-out light on an active runway is not a cosmetic issue. It is a notifiable event. Security operations at this hour are reduced, but not absent. Airside patrols continue through the night. The perimeter fence monitoring system, cameras, ground sensors, patrol vehicles, operates continuously. At major airports, the perimeter can stretch for miles. It is monitored in real time. At 3 a.m., the terminal begins its quiet transition. The overnight cleaning operation moves into its final phase. Food and beverage stalls complete their restocking. Deliveries that arrived hours earlier, pulled from cold storage, rotated for freshness, priced, and positioned before the morning rush. The check-in desks, empty now, screens dark, are scheduled to reactivate at 4:30 a.m. for the first wave of early morning departures. Before then, the systems team will run diagnostics on the check-in kiosks, the bag drop scales, and the boarding pass printers. 80 desks, a single technician, a practiced routine. The baggage handling system, the conveyor network that runs beneath the terminal, is tested before each operating day. Belt speeds are checked, diverters are triggered manually, Barcode scanners are calibrated against test tags. The system handles thousands of bags daily. It cannot start the day with a fault. At 4 a.m., the first crews of the day begin to arrive. Not passengers, airline staff, gate agents, check-in supervisors, ground handling coordinators. They come in without announcement, badge through security, collect briefing sheets from their operations desk, and begin the handover from the night team. The handover is not ceremonial. It is detailed and functional. The night shift supervisor runs through a status list: which aircraft have been serviced, which gates are confirmed clean, which equipment is temporarily offline, and which issues, if any, were flagged and escalated. Nothing is left to assumption. Outside, the tarmac activity intensifies as the early rotation begins. Wide-body aircraft that arrived from long-haul destinations the previous evening are now being prepared for their outbound sectors. Their cabin crews have been resting, their technical crews have been working. The flight crew has arrived. They come through the crew reporting center, a separate facility from the passenger terminal, where they receive their briefing packs, weather analysis, NOTAM summaries, and the final flight plan. They sign. They proceed. By the time a passenger boards, the crew has already been working for 2 hours. At 4:45 a.m., the first check-in desks illuminate, the screens wake, the scales calibrate, and the first passenger, almost always a single traveler, experienced, unhurried, approaches the counter. For them, the journey is beginning. For the system around them, it has been running for 6 hours. The immigration and security screening systems are already active. Officers who began their shift at 4 a.m. have run system checks, calibrated scanning equipment, and prepared the lanes. Security is not a reactive function. It is a proactive infrastructure positioned before the passenger population arrives. In the aircraft below the gate, the cabin crew is conducting their own pre-flight checks. Safety equipment is verified: life vests, oxygen generators, fire extinguishers, emergency lighting. Galley equipment is confirmed serviceable. Exit slides are armed. These checks take no shortcuts. Outside, the last of the cargo has been loaded. The ground agent closes the cargo door, not with a push, but with a mechanical mechanism and a visual check of the door seal from inside the hold. The door is locked. The locking pins are verified. This is not a moment for speed. This is a moment for confirmation. The passengers begin to arrive in the terminal. They move through check-in, through security, toward the gates. They buy coffee. They sit. They look at their phones. They are unaware of everything that happened in the hours before they arrived. They do not need to know. That is precisely the function of the system. The ramp coordinator is standing at the gate window, watching the aircraft. In their earpiece, a constant stream of updates: fuel completed, catering complete, bags loaded, cargo door secured. One by one, the status items close. The turn is almost done. The aircraft is almost ready. But the system does not always run smoothly. On a morning in late autumn, a hydraulic fluid leak was identified during the engineering check. Not catastrophic, but unacceptable for departure. The aircraft was taken offline, a replacement was sourced, 3 gates were reassigned, 40 connections were affected. The response to that failure was not chaos, it was the system doing what systems do when engineered for redundancy. The duty manager activated the contingency protocol, the operations coordinator reassigned the gates, the disruption was absorbed, the morning schedule recovered with a 30-minute displacement. This is what redundancy looks like at system scale. It is not dramatic. There is no alarm, no announcement. The contingency absorbs the disruption, and the surface, what the passenger sees, remains ordered, controlled, normal. The system protects its own appearance of normalcy. At the gate, boarding has begun. The gate agent scans each boarding pass, not just to permit passage, but to confirm the passenger against the baggage reconciliation system. Every scan is a data point. Every scan closes a loop in the departure sequence. Below, the pushback tug is already in position. The tow bar is connected. The wing walkers are stationed. The headset connection between the tug operator and the cockpit is live. The captain's voice will be the last thing confirmed before the wheels begin to move. Inside the cabin, the last passengers are taking their seats. The cabin crew runs the final head count. The doors are closed. The slides are armed. The purser calls the captain with the confirmation, all doors closed, slides armed, cabin secured. The aircraft is now a self-contained system. On the tarmac, the ground crew receives the clearance. The tug begins to move. The aircraft, all 200 tons of it, slides backwards slowly, the nose gear tracking precisely behind the tug. From the terminal windows, it looks effortless. From the tarmac, it requires complete attention. The tow bar is disconnected. The tug withdraws. The wing walkers clear. The captain acknowledges clearance from ground control and calls for engine start. The systems that have been dormant for hours, pressurization, hydraulics, pneumatics, come online in sequence. The aircraft begins to taxi. The ground crew stands and watches as it moves toward the active runway. This is their last moment with it. For them, this aircraft is already tomorrow's problem. There will be another in its bay within the hour. At the runway threshold, the aircraft holds briefly. Air traffic control is sequencing it into the departure flow. Other aircraft are landing. The slot is managed to the second. Then the clearance comes. The crew advances the thrust levers. The runway lights streak past. On the ground below, the terminal continues. The gate is already being reset. The jetway is retracting. A cleaning crew boards to do a rapid turn. And in the ramp control room, the next wave of arrivals is already being processed. Gates assigned, vehicles dispatched, teams briefed. The ramp agent, who spent the night loading bags, is now at the end of their shift. They debrief with their supervisor in 3 minutes. They collect their gear, sign out, and move through the staff exit. They will be back in 14 hours. They do not think of this as remarkable. It is simply the job. The night shift cleaning supervisor completes her final walkthrough of the terminal. She has been on shift since 10 p.m. She checks her last zone, the far end of Concourse C, confirms it is ready, and logs the completion. Her name will not appear on any departure board. Her work will be invisible to everyone who benefits from it. The fuel farm control operator logs off and briefs the incoming technician in the same manner as every handover, methodically. Temperature nominal, volumes confirmed, no anomalies logged, pressure steady throughout. The day team takes over, the night is officially closed. In the engineering bay, the aircraft that was taken offline is being repaired. The hydraulic line is replaced. A new system test is run. The engineers sign off. The aircraft is returned to service. It will fly again this afternoon. No passenger will know it was ever grounded. By 7 a.m., the terminal is fully operational. The check-in queues have formed. Security lanes are at capacity. Coffee shops are serving. Departure boards refresh every few minutes. The airport presents its daytime face, busy, ordered, effortlessly functional. Everything the night shift built is now invisible. This is the visible layer, the layer the airport presents to the world. What the architects designed, what the branding shows. But underneath it, in the baggage halls, on the tarmac, in the tunnels, in the control rooms, another layer existed tonight and will exist again tomorrow night and every night. The night shift ramp agent who spent 8 hours on the tarmac will not be acknowledged by the morning passengers, not because travelers are ungrateful, but because the system is designed to absorb its own labor, to make the effort disappear into the outcome, the clean gate, the loaded aircraft, the on-time departure. There is a phrase used inside airport operations, one you will not find in any marketing material. The system works until it doesn't. It is not cynical. It is technical. It is a reminder that complexity, when managed well, becomes invisible. And invisibility, in this context, is the definition of success. Every airport around the world runs a version of this. Smaller airports with smaller teams, larger airports with deeper hierarchies and more complex systems. But the architecture is the same, a hidden operational layer that exists to support the visible passenger experience. The ratio is consistent, one visible worker to many invisible ones. The airport does not celebrate its night operations. There are no ceremonies, no announcements at dawn saying the overnight teams have completed their work. The shift ends, the next one begins, the system continues. This is by design how it should be. The language of aviation is precise by necessity. Everything has a name, every role has a defined boundary, every action has a paper trail. This is not bureaucracy for its own sake. It is a system where the cost of ambiguity is too high to allow. The precision is the safety, the paperwork is the protection. The airport is in many ways a microcosm of every large operational system. It is infrastructure, it is logistics, it is human coordination, it is controlled risk, and it runs successfully tens of thousands of times every day across the globe because somewhere in every one of those airports, a night shift made it ready. As the morning deepens, the handover completes. The day shift settles into its rhythm. The same rhythms, the same sequences, the same careful coordination, only now in daylight. The baggage handlers, the gate agents, the dispatchers, the catering teams, the cycle continues. The first flight of the day has reached cruising altitude. Its passengers recline, open their laptops, order coffee. They do not think about the fuel calculation performed at 1:30 a.m. They do not think about the engineer who caught the hydraulic fault. They think about their destination, as they should. This is the measure of a system working as intended, not the applause, not the recognition, the absence of incident, the smooth departure, the full aircraft, the passenger who has no reason to notice anything. That absence of friction, of failure, of notice is what the night shift leaves behind. Tomorrow night, it will begin again. At 11:30 p.m., a shift supervisor will unlock the operations room. A fuel technician will begin their rounds. A cleaning crew will board an aircraft. A ramp agent will receive their assignment sheet. And the terminal, which appears to sleep, will do what it always does. Keep working. Most of us will never see this layer. We will arrive at our gate, drink our coffee, board our aircraft, and fly to wherever we are going. We will experience the output. We will never observe the input. That is what makes it worth documenting. The gap between what is seen and what is true. The airport before the first flight is not a mystery. It is not secret. It is simply a system doing its work, quietly, competently, continuously, in the hours before the world notices. And understanding it, even from a distance, changes how you see the machine the next time you board. Under this video, there's a subscribe button. It's a small action, but it helps reveal the systems most people never notice. If you're curious about how everyday life actually functions, consider subscribing. And tell us, where are you watching from? Have you ever worked behind the scenes of a system like this?